So I'm not going to go through all of I won't go through the equations so that we can get through both problems I want to today, but I will draw the diagrams that we would be using. So for the external picture, we have those three applied loads of 20, 30, and 40 kilonewtons, placed 2 meters apart. So that would be our external free body diagram. So again, there's three unknowns in it. I can call this diagram number 1. So if we wrote sum of forces x, sum of forces y, sum of moments, we're going to get out those three supports, and gy we will get 33.3. Oops. 33.3 kilonewtons. And ay will be 56.7. And ax would be 0. All right, so before we don't have to worry about method of joints, method of sections yet. Statically determinate, probably a good first, usually a good first move. Now you will see there was one problem in the homework that was statically determinate, and you could solve it without finding the external free body diagram for that one. But I'd say most of the time, in the types of problems you encounter, you will want to solve for these support reactions. All right, so now we want to look at what is it asking us to solve. We only need these three members, the forces in these three members. So what is a possible first internal picture we can make?
Can we do a section cut through JK, KB, CD?
Laser's not working here. So you want to cut through, if we cut through JK, DK, and CD, I mean, we could do that, but that's going to be three unknowns, none of which we're interested in, because we won't see HI, EF, or DE in that picture. So it's a viable cut, but kind of the rule of thumb is going to be cut through as many unknowns we're interested in as possible, because if we don't cut through them, they're not going to be, we won't be able to see their force in the picture.
Yeah. Can we take the section cut where the object of interest is GFH?
Right, so what members would we be cutting through in that case?
HI, HE, and EF.
Right, so if we made a section cut through HI, EH, EF, first of all, that cuts through two of the members we're interested in, and it cuts through only three total members. So it will be a solvable system, two of which we're interested in. Now, ideally, we would want to make a cut through HI, EF, and DE, but if we look at our picture, there's no way we can cut through those four members, or three members, and cut through only those three members. So there might be a cut that includes all of them, but we'll have more than three members in it. So I would recommend against that cut if we're solving this by hand. So if we make the cut that I was just talking about, two of the members we're interested in, the third one is kind of along for the ride. So we won't be done at that point, but we'll be 2/3 of the way done. So I would recommend as our next move, cutting through those three members. So we're keeping intact GFH. Those are not going to be cut through, so we copy what's happening there exactly. We have the number for GH. GY is 33.3. Oh, I'm cutting through those members, and like you suggested, I'm keeping everything to the right. We could keep everything to the left and still get an answer, but again, as a rule of thumb, I recommend keeping the smallest picture possible so that it's less to write in your equations and less just to worry about while you're solving this. So I cut through HI, EH, EF, and keep everything to the right. So there's no external force at H or at F, so those just are going to remain where they are. And now I have to include the members that I'm cutting through here. And now I will be able to see what their internal forces are. So I'm cutting through HI, so I can see now the force in HI. I'm cutting through EF, so I can see the force in EF. And I'm cutting through EH, so I have the force in EH. And then this makes a 2, 3, root 13 triangle if I want to express it with ratios, or I could use angles. And I know this is 2 meters, and then this is 3. So a total of 3 unknowns in my picture, 2 of which I ultimately need to find, and one of which I'll need to find in order to find the other two. All right, questions on this picture or why we chose this section cut? All right, so going through this will get us two things we need to know. So if we sum, let's say, forces in the y first, we can find FEH. Will be the only unknown in that. So if we find FEH, it's 40 kilonewtons. If we then took the sum of moments around point H, FEF will be the only unknown. So we can solve for FEF that way. So that is one of the members we were asked to find. So 22.2 kilonewtons at its intention. And then lastly, if we sum forces in the x, once we know these two, then the last thing we need to find is FHI. So FHI will get a negative 44.4 kilonewtons, and that will be in compression. And again, that was another unknown that we were asked to find. All right, so two of the unknowns down, we still need to find DE. So now we want to reassess. Do we want to make another section cut? We could at this point make a pin diagram, but we have to decide which section cut or which pin should we look at for our next picture. So again, thinking about in terms of what's the easiest to do, what's going to be our next easiest move to find DE at this point? Right, so at this point, now that we know our external forces and we now know three internal forces, if we look now at the pin at E, it is attached to four members, but two of them we just found in the second free body diagram. So there's only going to be two members on this pin that we don't know at this point, which means we will have a solvable system. So on point E, we have the force in DE. We'll have the force in EF, which we do know is a number, but in the picture, I'll keep it as a variable. The force in EI, which we do not know. And then the force in EH, which we do know from the previous step. All right, so again, four members, two of which we already know from the previous step. So looking at free body diagram E, if we sum forces in the x direction, we know FEF, we know FEH, so the only unknown in that equation will be FDE. So solving forces in the x, we can get that FDE is 40 kilonewtons. And that would be in tension.